Hi, everyone. Thanks for tuning into the Printed Circuit Podcast, where we'll discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. In this episode, we'll focus on constraint-driven design, and here to join me in this discussion is my very longtime dear friend and industry colleague, Scott Decker, a technical lead designer at one of the largest and industry-leading mil-aero companies. Thanks for being here.
Hey, Steph. Thanks for having me.
Scott, can you give us a brief introduction of yourself and your background?
I've been board designing for a little over 30 years or so now. I started out on Mentor Tools in 1990. I came forward with pretty much Mentor exclusively through this whole time frame. There was one brief period of time where I actually worked on a different product that was actually just designed by guys from Mentor, so it wasn't much of a change. But otherwise, all the way from Port Station up to Expedition now, and probably the last 11 years on Expedition. I've done boards from basically simple 3-component boards to hundreds of components, thousands of components type of thing. Everything you can imagine, power supplies, microprocessors and stuff, and the like, if you will.
Yeah, Scott, I think one of the awesome things I love about your background that I at least want to mention is that you're a train guy. You're an old school train ham radio guy. So I think that plays to your strengths of when you're designing boards is the fact that you come from that ham radio Mars Graham type stuff that we talk about getting it right and doing it right. I love that background that you have.
That's the thing, and so is the ham radio stuff. A lot of these guys will have tons of equipment, all that. I always tell them it's a hobby, not a lifestyle, but so is train watching once in a while too.
So we've been blessed to work together for easy over 20 years. And whether we sat side by side in a queue, which we've done before, or across state lines, you and I have collaborated quite a bit. And when it comes to designing constraints or constraint-driven design, when I thought of you, when that topic came up, I'm like, I got to talk to Scott and have a podcast with Scott. So when we talk about constraints, I want to get into it and I want to know what doesn't work when it comes to constraint-driven design from your perspective.
Well, basically, the way I look at it is that in the past, probably starting maybe 25 years ago or so, or maybe a little less than that, constraints really weren't a big deal in a lot of the industry because designs and circuitry and things like that just weren't running that fast. And as you know, our buddy Rick has always made that same comment that you can get away with just about anything 25 years ago. What doesn't work today with constraints is the fact that if you don't have them, there's a lot of designs just flat won't work when you get done with them. They'll look nice maybe, but they just won't work electrically. And so I look at the idea that a design that doesn't work with constraints is, for one reason, somebody didn't set them up properly perhaps, or they didn't set up the proper ones in the first place to have their design be successful when they're all done with it. On the opposite coin, designs with constraints are going to be much, much better at the end of the design cycle. And setting them up, a lot of times we look at management, sometimes engineers and things like that are wondering, why in the world are we doing this and taking the time up front to set this up? And it's basically because when you do it up front, you don't have to fix it when you're done. And that's what will end up usually happening is that you'll get something all done and everybody says, hey, by the way, are those lines matched? And you said, well, you didn't tell me about that. And so now I get to go back and fix it. But if you had told me that ahead of time, I would have had the system already match those lines and we wouldn't be having this conversation again. So it's a two-headed sword, so to speak. You have constraints, they have to be set up correctly. And if you don't use them, you run the risk potentially, and I won't say that on every design because there's a lot of designs, you can still get away with a lot of stuff. But without the constraints, that you have a higher risk of an unsuccessful design, especially in today's circuit designs that are out there now, high-speed stuff, RF stuff, fast digital, things like that too.
Aside from designing correct by construction, by implementing constraints, I think what I love about the constraint is when you and I have sat in meetings where they've asked, how can you prove that you did that you're meeting the requirements? Well, it's easy. You could pull up the constraints and say, look, here's the rule or here's the constraint. This is what it checks for. I don't have to think about it. It's there. It's guarantees that I'm not going to break that rule unless you turn your DRC off, which you and I both know that's a huge no-no. I hate to say it, but people have bad habits and they do that. But those constraints, that's what I love about it.
And the other thing too is, of course, like, and you mentioned it, is that when somebody wants to know, well, how do you know that you've done this correctly? And if you review the constraints with the engineer or whomever, and then you show them your hazard report, and you say, look, nothing here. I've met the constraints that I've set up. And obviously, if you run the risk of having something set up incorrectly, but that's usually a situation where, for me, for instance, I'll set those constraints up and review them with the engineer to let him know this is why I did what I did, and is this what you really want? And that's typically the answer I'll get would be that yes, that's correct, or no, I was looking for something like this. And in some cases, engineers are saying, oh, you can do that? And I'm like, yeah, absolutely. And not to mention the fact that not only can I do that, but I need to do that in order to meet your design requirements. That's all there is to it. And they appreciate that. And I'm generally educating them on the use of the tools and the constraints, the constraint manager in this case. So they appreciate that too, because it helps them in the next design of theirs, that they'll have a more successful design themselves.
Absolutely. I couldn't agree with you more on that. And I think you and I both sat in meetings where we've had to defend, well, why did you do it like that? When we bring up the constraints and we bring up the requirements and say, look, here's the requirement, here's how we implemented that, and here's how we guaranteed that we were going to meet that constraint. And then you have the aha moment that you see in the project managers or other managers or directors' eyes, or even better, when the customer asks that question, well, how do you guarantee that you met this requirement? The current constraints is an easy way to show, because a picture's worth 1,000 words. And then you show here's the rule, here's the requirement, here's the constraint that meets that, and that locks that requirement in.
As an example, too, on a current design that I'm working on now, too, is that we have high voltage and low voltage stuff. We have to maintain a separation between the high voltage circuitry and the low voltage circuitry. And without constraints, you have a good chance of failure unless you can absolutely guarantee that your placement is going to guarantee the end routing for that matter, too. You can guarantee you never cross those two things or get them too close together based on the requirements that they're requiring. By adding the constraints in there, and you know this from how we used to do it before, you put in a net type rule to net type rule clearances on things, and the system just flat won't let you do it wrong. Obviously, there's always an opening for human error to import or set something up wrong. But usually, we review these things and we look and say, okay, this is correct. I need to fix this and all that. But the bottom line is, when you get all done with it, everything is going to be guaranteed to be correct. Unless, like you say, you turn checking off. And as we both know, we've rarely had to do that. And I even tell my colleagues and stuff too, there are times when you turn checking off, and there are times that it's necessary. But I can only think of about 5% of the time you work on a design that checking is not turned on. If you can't get it to do what you want it to do, something's not set right.
Exactly. You can over-constrain your design. With that said, this leads me into my next question for you is, we know what the problems can be. What is the solution or the best practice for PCB designers that they should implement when you think about this?
Well, first of all, it's like anything that we start on with a design. First thing we have to have is, what are the requirements for that design? What do we need to do? What is the end result of the product that we're working on? For starters, we're always going to ask questions like, do you have controlled impedance? Do you have high current lines? Do you have sensitive lines that need to be protected, or that type of thing, differential pairs, LVDS stuff? These are things that every designer should be asking up front on every design, especially in these newer high-speed designs and things, or even on some of the more complex RF designs, things like that. You always need to have what are the expectations and the requirements that design has to be. They're not always going to be the same from one board to another. There'll be some common things maybe, but for the most part, every board is going to be unique. So that means you have to ask those types of questions for every design. Then you have to be able to understand those requirements so that you can properly implement them into CDS or into a constraint management system, and understand how that constraint management system is going to work to help you as opposed to hinder you. Because I do see some cases where people will do this, as you said just a moment ago, over-constrain things. I tell engineers and other designers, my favorite saying is, with power comes responsibility. So when you have the power to constrain things, be responsible about it and don't over constrain it to the point where, and I think I've seen this in the past too. The engineer says this line can't be any longer than 2 inches, but the parts physically won't be any closer than 4 inches together. So you failed. You failed right out of the gate. You didn't even get a chance to try it. So that kind of stuff can happen. In addition to that, and as I was just mentioning, with those constraints and understanding them too, that can also lead to proper placement because of those very same rules that we were just talking about. If you have a length rule in there or a timing rule that says it can only be a certain length and so on and so forth, you physically can't put the parts further apart than what the rules allow. And that's another thing that the constraint editing system will help you with, is that if I put something too far away, it's going to let me know that. Or if I put it too close, it's going to let me know that too. So I can't emphasize it anymore. It's designed to help you be successful as opposed to fail. And obviously, like I said, anybody can make mistakes when you enter this stuff, so you do check those things. But ideally, when it's complete and it's all correct, you just, I won't say you can't fail, you have to work at it to fail. Maybe that's a better way to put it.
You and I used to always get a lot of flack about why is it taking so long in the beginning? We're not seeing enough traction. Well, it's because we're getting all the constraints all locked in and dialed in because it's going to go so fast at the end. Why? Because you don't have to do any hardcore checking. The system is guiding you according to the constraints that you've added and the rule sets that you add that are meeting your requirements. And that's the key. And I think working closely with the design team or your EE up front. And I always feel that the constraints, for the best way to do it is to do them up front. Get them up at the creation of schematic. That EE is adding to those constraints. One of the best way, in my opinion, is to have constraint templates set up so you can bring in, as for example, if you're doing a high power design, you bring in a high power constraint template. You import that in and it already has net classes and constraint classes set up. So that way the EE is easy for him just to assign them to the nets, the appropriate nets. And well, we've created these constraints and been very successful at it. And I think I learned a lot from you early in my career of asking the right questions. And I love what you said is asking the right questions to the EEs to make sure that we understand what they want and what their intent is. So that way, when you finish the design, it's exactly what they wanted and you're not having to go back and check. And I think that's key. And that's one thing that I think that one of the strengths that I learned from you early on in my career as I evolved.
Absolutely. And one of the things that you and I have even been over in the past also is the fact that communications is key. You communicate with your fabrication companies and that to get the information that you need. And you need to communicate with your engineer what they're looking for. Communications, understanding what that engineer is looking for and making sure you understand how to implement what he's looking for is a key factor too. So the constraints are powerful tools, but if you don't understand what it is you're trying to put into that constraint, then that can also be kind of a hindrance to you too. So being sure that you understand and that communication is, like you're saying, back and forth I mean, it's like they always say, no question's a dumb question except for one that's not asked. So I will ask the same question sometimes to multiple people, even though it may sound like a dumb question, but sometimes you glean a little piece of information out of that you didn't know, and then all of a sudden it's not a dumb question anymore. It's actually something that's very helpful, and you realize that it's required when you weren't even aware of it, perhaps, and that's what helps you get into those constraints to say, oh yeah, he mentioned this, and I can set that up, or I can make sure I don't set myself up by accident for failure too. So there's just a lot of things that go wrong, but there's a lot of stuff that can go very, very right just from communications.
You've mentioned and shared quite a few different examples. One of my questions I was going to ask you is to walk me through some examples of how it works, but you shared a little. Is there anything else, any other good example that you'd like to share or that you'd be willing to share where you did the constraint upfront and how it helped you be successful at the back end to really solidify that constraint-driven design is the best practice approach to PCB design?
For instance, from our past and company work in the past and everything with the high voltage and low voltage stuff, for instance, setting up the constraint says we have to keep high voltage stuff a certain distance away from the low voltage stuff. or chassis crown. Those were very successful situations because we didn't have to worry about checking it. And when you did look at something and an engineer or somebody looks and says, that looks awful close, and you said, but it's within the spec and I can show you and I'll measure it, then they're like, oh, okay, that's great. Other designs where we've had, other designs where I've had perhaps a timing topology that I had to be very careful for, which we didn't mention topologies, but that's in part of that constraint editing system too. We want to make sure that we went from this load to, rather this source to these three loads, but we wanted to make sure they were all the same length, or we want to have a star point out there someplace. These are things that I've done in the past, and even in times when the constraint manager didn't really do some of the things that I asked it to do. But if we understand how it works, sometimes we can create that, and now these tools are in place in the tool now. So we can put virtual points out there to guarantee DDR stuff, where we can do templates like you had mentioned. That's one of the things that we're working on too, at my company too, is to get templates established for things so that we can carry things from one design to another and be more common about stuff. And plus it helps set up things much faster too. So it's a time saver. And like you said, people ask, why do you take so much time up in the front? It's just like the way we used to do it before, is that a good placement will yield a good routing almost 90% of the time. Sometimes it's the luck of the draw and things don't work right. But when you have good placement and the constraints are set right, the routing is going to go really easy and the design is going to be done in a much faster time frame, and it'll be correct when you're done.
Exactly. I mean, when you think of the three perspectives when it comes to being successful with board design, solvability is the first perspective. And in that is mastering your CAD tool. Then that leads into the performance because, like you said, you have a certain distance or a certain length that trace has to be. Well, if you placed it too far apart, you could exceed that. And then no matter what you do, you're never going to meet that requirement. So the solvability ties into placement or performance, should I say. And then with that, when you design your board, it's got to be manufacturable. It's got to be producible. And you want to have high yields and low cost. You want to be able to produce a lot of them at a very cost-effective way of doing it. So, when we think about the key perspectives, I mean, design constraints or designing constraint-driven design leads into that, in my opinion. And I think you would agree with me on that.
Absolutely. If the constraints are set right, the design is properly designed and meets all the constraints and passes all of the checks, as you do your DFMs for manufacturing, and if you have to fix things there, you can do it, but as long as the constraints are in, you can fix it. Be confident you're not going to break something. And then when you get your DFM checks all done, when you're ready to go to production for it, or even prototype runs, you know at least from the beginning in the get-go that your design is going to be good. I always even tell the younger designers that I've worked with in the past too, it may just be a test board. But the point is that if you design it to the best of your ability, then when the engineer gets his test board on his bench, he knows that the board is right. If it's his circuit that's not working correctly, then that's on him. But if he says, I don't know if the board's doing this or if my circuit's doing this, there's two variables, there's too many things, there's too many things. It needs to be one variable at a time kind of thing.
Don't even get me started with bad habits, with designers having bad habits. And it's one thing I learned early on, and as you and I evolved our careers together, is it doesn't matter whether it's a small, simple board or very complex. I mean, you treat them all the same and you bring your A game to the table because you don't want to start getting bad habits and producing garbage.
One of the companies I work for, one of the things that the president of the company said is that now that we have good quality board design here, the emphasis is on you guys, and he was referring to the engineers, that you guys need to make sure your circuits work because we've taken the board factor out of it because they had a lot of problems with the board design in the past. So it makes me feel good, but for a company, everybody needs to do their right job, and constraints is just one of those things that you need to do right.
Exactly. Scott, you've got even a longer career runway, or should I say, you've had a longer career runway than I've had. I'm a little over 30 years in the industry. When you think about when you started in your design career to where you are today, and you see the roadblocks in implementing the best practices from today, what do you see have been the roadblocks to prevent these best practices that have been implemented, especially when you really take a step back in your career and say, now that I know the best practices, what are the roadblocks that you see that are preventing companies from actually implementing it?
probably the biggest stumbling block or roadblock, as you want to call it, is the education of the designer themselves. Oh, and you know this as well as I do too. The abilities to go to places like PCB West, PCB East, for instance, or user-to-user groups, things like that for designers is really important. And it's sad for companies that decide that, that's just not something that they want to do, or they believe that, well, we can teach what we want you to know from the inside. It closes off the mind of the designer to, I only need to know or only learn what the company wants me to know, as opposed to what I can learn for myself and maybe bring to the company. So with that said, I say one of probably the bigger issues that would be is the educational side of things. My manager, when I first became really doing board design back in 1990, I wanted to go to PCB West so bad. I couldn't. It was the second year that they had it. I read the article in the the PCB Design magazine at the time. They said how to get your boss to send you to PCB West, and I wrote him a page and a half. And I pointed out all these things. I walked in and I handed it to him, and he said, "I'll think about it. I'll be back in a little while later." And he says, "Well, he says I want you to pick 3 best days because I can't have you go for the full week." And they had a full curriculum. And I thought to myself, well, how about if we send your child to high school, but just pick the 3 years out of the 4 you think are the ones that would be most beneficial. And I took the 3 days. I suppose if I'd have been smarter, I said, well, I want to go Monday, Wednesday, and Friday, and then let him figure out how to send me back and forth on Tuesday and Thursday. I don't think so, but I was just happy to go. But that educational experience, an eye-opening experience for me as a new designer myself at that point, really was a huge eye-opener. And it really made me start looking at the fact that there's a lot of education out there and a lot of places to be educated for this kind of stuff. And so companies need to really embrace that more so, I think, than what some of them do now. And as you know, there's others that will, hey, we'll send you there, and they don't have a problem with that at all. Bring the information back. That's all they ask. And I never have a problem doing that. I mean, let's face it. It builds your career up, and it gets you smarter, and it lets the company know that, hey, this person is really learning these things, and they're bringing it back to us. So it's a win-win for them, too.
Yeah, I agree. It's an investment all around. I think education is key. And then especially when it comes to board design, it's the basics that people tend to get wrong, and the very basics. You compound it with truly understanding board design and then mastering the tools that we have today. I mean, when you think about your career from the very beginning, the manual approach in those tools to what we have today and the feature-rich tools and the horsepower we have, what is your take on that?
It's a night and day thing. Everybody did the best they could with the tools that they had at the time, 25 years ago. Now that you've increased them and you've made the tool capabilities much better, I mean, I can't even keep up with it. A mentor literally from one subversion to another subversion, there's things in there that I don't even know exist, and I stumble on them sometimes. I have a good example of that one too. I see that designers need to keep up with the tools as much as they can too, and companies need to help that too by allowing them to explore and learn and go places with the tools. But also the support group. I can't emphasize it enough with the mentor support group that we've had over all these years, even before you and I were together, and that has been just phenomenal. I still talk to some of the support people that I knew 25, 30 years ago almost. It's great. Everybody really helps each other out a lot. And so it's an evolved tool set from almost the Etch-a-Sketch days or the light table days to today. It's just literally tenfold, 100-fold better than it used to be. So it's a continuing learning process to go through. There's no question about that.
That was amazing summation. I think we've outlined, the best practice when it comes to constraint-driven design. I can't thank you again for your invaluable insight and time that you took today to share with our audience from your perspective and your experience as you being a designer. And I know you don't like to be called an expert, but you know how I always feel of you. So
I always have to go back and mention Gary Owens. Some people know who laugh in the program once, but Gary Owens used to say, the next is a form of has-been, the spurts drip under pressure. And so you never want to be an expert on anything. I've said it in taglines in the past too. An expert means you know everything about something, and I don't know everything about everything. So because if I did, I wouldn't learn anything. I wouldn't have to. I know it already. So it's a little bit of a funny tag thing, but people have to continuously learn and grow, and especially in design work, because electronics doesn't stay the same. It keeps going. And if you don't get on board, the next trolley is not going to be around for a while. So you'll end up in the back of the bus for a long time if you're not careful.
Couldn't have said it any better, Scott. Well, thanks again to our audience. I'd say there you go, straight from a long time printed circuit designer who's been around way longer than I have and shared some great insight. So tune in to our next episode where we talk about advanced design capabilities like rigid flex and HDI.